Hello and welcome to Duotech. I'm your host for today, Harry, and in today's video we are going to be talking about RAM. We're going to be talking a lot about RAM, how RAM works, what it even is, and let's answer that question first. RAM, or Random Access Memory, is a temporary memory store, that's the key word there, temporary, that stores the information, instructions, data for programs that are running and basically currently in use. This is an important part of computing, as this can be read from really quickly by the CPU, and basically the quicker it takes to fetch the important information from the RAM and virtual memory, but we'll get to that later, the quicker it takes to read from these, the quicker that the whole FDE cycle can run. Which of course in turn improves the performance of a CPU. If you want to see more on that topic, I'll leave a card up there. I forget which side they appear on YouTube videos, but I'll learn. Now, RAM is quite different from ROM, which shares a similar name, but as I said, they're really different. ROM is read-only memory. Basically, you cannot write to ROM except for certain exceptions like EEPROM, which you have to wipe the contents completely if you hope to write anything to it. Basically, ROM is used mostly for the system BIOS on a motherboard, because that doesn't really need to be updated, and when it does, it can be completely wiped and completely made anew. EEPROM works by electrical signals, basically erasing and replacing information. Now, one big thing about ROM is it's much smaller in size and contents in comparison to RAM, because RAM needs to store a lot of information, ROM not so much. The contents of RAM get deleted when the system loses power, and ROM does not do that. The thing is, RAM doesn't need that information anymore once the computer is shut down, because no programs are currently running or in use. With ROM, it's storing a program that cannot afford to be removed every time a system goes completely offline. Now, a lot of people have the misconception that RAM sticks are the only form of RAM in the computer, when that is totally false. Basically, yes, that's the one that most people know, and I'm pointing to my computer as I say that. And these are two different types of RAM. The sticks that you commonly see on motherboards are called dynamic RAM, and these store information by transistors, and occasionally you might get a memory leak, so it has to be refreshed quite often, hence the name dynamic. This is a lot cheaper per gigabyte, which is why you see it in RAM, because you need high quantities of it. The other one, static RAM, is what you'll generally see in cache, and this has the opposite effect of not having leaks, so it doesn't need to be refreshed. It is, of course, a lot more expensive per gigabyte. Instead, the information stored in SRAM, or static RAM, is stored in capacitors. As I just mentioned, the abbreviations for these are DRAM and SRAM for dynamic RAM and static RAM respectively. The DRAM controllers are used for the sticks of RAM that you'll find on your motherboard, because obviously they're dynamic RAM. Static RAM not so much, because they use a separate controller, a dedicated controller that's integrated into the CPU. So there are many things that might affect the performance of RAM, and yes, much like the performance of a CPU, there are loads of different factors, not just one magic thing that you can go off to make an easy purchase. Basically, the clock speed of RAM refers to how many times in a second it can read and write. This is measured in megahertz, which is basically millions of hertz, and they can be marketed between 1666 and upwards of 3000 megahertz. It should be gigahertz, but for some reason they chose to go with megahertz. If you know that, please leave the reasoning in the comments, because I'd love to read it. But there is another factor that, or another major factor that is at play, which is the lesser known one. CL, or CAS latency, or column access strobe latency. Yes, a double abbreviation. That's how awesome it is. This basically refers to the amount of time it takes for the RAM to receive an instruction and actually do something about that instruction. This is measured in RAM clock cycles, which is weird because the RAM clock speed can vary wildly between RAM sticks. If you see a relatively high CAS latency but also a high clock speed, it doesn't mean that the delay is that bad necessarily. It just means that it takes a lot more cycles to pass for an instruction to respond. Ideally, you want to find some sort of middling ground with the CAS latency, depending on the clock speed. If you are installing RAM or you're building a new computer from scratch, please do yourself a favor and buy RAM sticks that look exact. Instead of buying one stick of 8 GB per se, buy 2 sticks of 4, same brand, same pretty much everything, and stick them in the alternating slots. This would do so much benefit to you, and it costs you literally nothing extra. Maybe a few seconds of time at most to unpack the RAM sticks from the packaging and installing them. That's it. Effectively, this would vastly improve the performance of your RAM, because basically the information can be accessed from 2 different channels at once, and basically this makes everything a bit faster. So what happens when RAM becomes full, or too full to store any new instructions? Because the CPU needs those, it can't function without those, right? Will it cause an error? Will it crash? Actually, no. Instead, a space or partition in secondary storage, this could be your hard drive or SSD, will make way for the new information, so that would be on secondary storage. The big issue with this is that it takes a lot longer to read from any secondary storage device, even the fastest SSD in the world, than it does to read from RAM, because obviously the buses that would have to transport the data to the CPU will take a lot longer to do so. And this causes the huge issue of severely bottlenecking literally everything in your computer. Everything will become a lot slower, and you'll severely regret ever living. So if you are intending to do something on your computer, please do yourself a favor and get enough RAM to do that. And further additional research can be conducted into how much RAM you should actually get. There are probably some great videos on it on YouTube if you want to go search for that. I might leave some in the description. So my cat has decided to join. Say hi to Pringle. You might see when purchasing some RAM or a motherboard that it is DDR4 or DDR3, DDR2 or DDR if it's really old. And basically this doesn't really affect the performance of the actual RAM. It's more to do with power conservation, because DDR4 has an overall lower voltage than DDR3, meaning that there is overall less power draw. In terms of raw performance, there is actually a bit of an increase between DDR4 and DDR3. However, it's pretty much like maybe a few frames at most. It's really not much. But generally speaking, DDR4 also has a higher range of clock speeds than DDR3, and that could pose a boost in performance should you get some higher RAM speed. And overall, you can get larger sticks of DDR4 than you can for DDR3, because they found a way with DDR4 to pack more data in a smaller space, so there's a higher density of memory. Now keep in mind, the actual power of RAM, or how good RAM isn't 100% hardware. There is a software element to it as well. And this is managed mostly by the operating system, namely the central part of it's called the kernel, which manages other stuff too, like CPU scheduling and things like that, which I might get to in a future video. But basically what you need to know is it can split the processes of RAM into paging and segmentation, which are two different ways to manage memory. Paging splits into fixed size blocks, while segmentation splits into variable size blocks. And these have their various advantages and disadvantages, which I will again get to in a future video. So that is a bit of a breakdown on RAM and how it works. Sorry if the presentation was a little bit of a train wreck. I really need a teleprompter or something so I don't have to look at my monitor all the way over there. It really sucks, but you have to start from somewhere, and ow, clawing my leg. But anyway, if you found this video helpful or you did enjoy it, please be sure to leave a like, comment, and maybe even subscribe for more. And also, if you really enjoyed it, maybe share it with your computer science class. I wouldn't be opposed to you doing that. Could actually help us gain a bit of traction in the early days of YouTube. Anyway, thank you for watching, and I will catch you all hopefully in the next video, either next week or the week after, depending on when Logan releases his video that he just announced on Twitter. See you then.